Good evening friends, and then what we are discussing, definite integration as a limit of sum. In the previous video we discussed the idea of the definite integration as the limit of sum, and then we solved two questions also. Here also in this video we are solving two more questions just to remove the doubts and worries from your head, because I'm not convinced that you have all understood it well. So question number 1, this is NCERT textbook again. This is question number 4. So this is question number 4, and this is 1 2 4, and fx is x square minus x. This becomes little lengthy, that's why we feel that whether you understand it well or not. So if I break this down as two parts, like one is 4x square dx minus other is 1 2 4 x dx, and then I solve them one by one, what would be? So I think this is the better idea. You can understand both of them one. So first I solve this one, that I is 1 2 4 x square dx. In this case a is 1, b is 4, h is b minus a over n, that is 4 minus 1 over n, that is 3 over n, means nh equal to 3. nh equal to 3. Then I expand, limit h tends to 0, h times first we have to write the formula, so let me write the formula. fa plus h plus dot plus f a plus n minus 1 h. Then limit h tends to 0, h fa, what is fa? This is 1, and what is fx? This is x square, because fx here is x square. So what is f1? 1 square. What is f1 plus h? 1 plus h whole square, plus what is 1 plus 2h whole square, plus dot plus 1 plus n minus 1h whole square. Now expand and regroup. So limit, first here I change the limit. I make the limit n tends to infinity. At the place of h, since nh is 3, then what is h? 3 over n. So 3 over n. Now there 1 square plus, expand this. This is 1 square plus 2h plus h square. Next one is 1 square plus 2 into 2h plus 2h whole square. This I put in a curly bracket, plus final one, that is 1 square plus 2 into n minus 1h plus n minus 1 square h square, like this. So this is 2 into 2h, 2 into is 2 into 2h into 1, 2ab, so 2a and this is b. Okay, now the proper grouping again. Here you have to pay attention. Then limit n tends to infinity, 3 over n. Now just look at the first terms of each sequence. There are n brackets, 1 term, 2 term, 3 term, n terms. So 1 square is 1 times 1 square 1. So 1 is 1 plus 1 plus 1. So you have like this 1 plus 1 square plus 1 square plus 1. This you can type as n times. Got it? Now second one is 2h, middle term. This middle term I am going for this. But since this term does not have any middle term, so we can say there is just n minus 1. Now you see 2h, 2 is everywhere, so you just take common. So I say 2h common. Then what I get here, I'll get 1. No box. 1 plus, if you take 2h common, 2 plus 3 plus dot, final one will be n minus 1. This is done. Plus, then this one h square, 2h square, n minus 1 h square. Take h square common. then you have 1 square plus 2 square plus dot 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 plus n minus 1 square h square, we have already taken common box. Now limit n tends to infinity, this is 3 over n. If you add 1 n times, this becomes n plus 2h. This is the sum of n minus 1 natural number, that is n minus 1 by 2, n minus 1 by 2 plus h square. This is the sum of square of the first n minus 1 natural number. So this becomes n minus 1, 2 minus 1 whole by 6. So this part is done here. Now I need to solve it precisely. So I want to remove everything so that you don't have any doubt. And I am retaining this nh equal to 3. This you need to remember. nh equal to 3. So what do we have now here? That limit n tends to infinity 3 over n. Now see, 3 over n is here, h is here, and this is n square, h is there. So I write first properly, then I'll discuss. 3 over n plus 2 and 2 cancel, you can cancel. So this is nh n minus 1 plus this is h square n minus 1 2n minus 1 whole upon 6. Okay, so first, before taking anything out of this one, I would like to go change the idea a little bit. So I take n, I take one n common out of this. Okay, so what you get? You get, okay, now I think I should first let me get rid of this 1n. So I take 1n common, so this becomes 3n over n. This is 1 plus h n minus 1 plus h square. This n is gone because I have taken common. So n minus 1 2n minus 1 by 6. Okay. Now here you just pay little attention and your job is done. This is n tends to infinity. So what you need to do, this 3n by 3n, this is cancel only 3. So here you are seeing we are getting nh, fine, we need nh because nh is 3. Now here you take n common, 1 n common from this and 1 n common from this. Then this becomes n square h square. Now how? So this becomes limit. Okay, let me clear this part of screen also. Limit n tends to infinity, this is 3. Now this is 1 plus, I can expand, I don't need to expand right now because I want to take n common. So if I take n common, nh, and this becomes 1 minus 1 by n, plus here also you take 1 n common from this bracket, 1 from this. So this becomes n square h square. This becomes 1 minus 1 by n, this becomes 2 minus 1 by n and whole by 6. So now you see what is nh, that is 3. Now if you put the limit n tends to infinity, then 1 by n things will become all 0. But before that you have to replace these values of n square h square by their respective values. What is nh? This is 3. So I replace this one here. Then what this becomes 3. What is n square h square? 9. So I replace this one 9. Now you put the value of limit as n tends to infinity. Wherever you have 1 by n, that will all become 0. So what you get? 3 times 1 plus this is 3. This becomes 1, this becomes 2. So 9 2s are 18 by 6. So this is 3, 6 3s are 18. 3, 3, 9 and 1, 10, 3s are 30. Your answer is 30. Now check whether I get this answer as 30. So what is integration of x square? That gives you x cube by 3. Now what is x cube? That is here 1 and 4. So this is 4 cube by 3 minus 1 cube by 3. This is 64 by 3 minus 1 by 3. So 64 minus 1 is 63 by 3. Then what you should get? 21. And what I have got? 30. This is wrong. It means where I made a problem. So this is 3. This is 3. 1 plus 3. Oh my god. This is 3 and 3, 6, 6 plus 1, this is 7. This is right. 3 and 3, 6, 6 plus 1, 7, 7, 3 is a 21 and 21. I don't know, I just thought 6 is a 9, I think I made it 10. So 21 and 21, so these two are same. So this is how this question can be solved. I have to do the same thing for this, and I think this guy, you are sufficient, smart enough to do it on your own, and then you find the difference of these two. Now I go for another type of question that is there in this exercise, and that is for e to the power x. I'll do that one, and that is the end of this series of definite integration as a limit of sum. Now this is question number 1, 2, 3, 5. So this goes like find I as -1 to 1 e to the power x dx. So we have a, this is -1, b which is 1, this one, this is a, and this is b. Now we have h is b minus a over n, that is 1 minus 1 minus 1 over n, that is 2 over n, and this is h, means nh equal to 2. Then we write the formula. This is first limit part. Limit h tends to 0, h, and then you write fa plus fa plus h plus dot 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 plus fa plus n minus 1 h. This is limit h tends to 0, h. What is fa? A is -1, and what is fx? That is e to the power x. So what is f of -1? This is e to the power -1 plus -1 plus h, that is e to the power -1 plus h plus dot 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 plus e to the power -1 plus n minus 1 h. Now I replace the value of limit as n tends to infinity, limit n tends to infinity, and at the place of h I write as 2 over n. So 2 over n. Now you see e to the power -1, this can be written as e to the power -1 plus e to the power -1 dot e to the power h plus e to the power -1 dot e to the power 2h, which is hidden there, plus dot 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 plus e to the power -1 into e to the power -1 h, like this. So I take e to the power -1 common, then this becomes 2 e to the power -1 over n, and what I get? 1 plus e to the power h plus e to the power 2h plus dot 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 plus e to the power n minus 1 h, and this is limit n tends to infinity. Now this is a geometric series, and the sum for the geometric series goes as a r to the power n minus 1 over r minus 1 when the mod r is greater than 1. So this formula we'll use here. So what is a? A is your first term, that is 1. So this is 2 e to the power -1 over n. A is my first term, that is 1, into r is e to the power h to the power n. But here we have, this is starting from 1, this is n minus 1. So e to the power n minus 1 over r minus 1, that is e to the power h minus 1, e to the power h minus 1. So this whole thing is just nothing but 1 into e to the power, what is r? r is this is nh, e to the power nh minus 1, and this 1, this is fine. So this is limit n tends to infinity. Now let me remove this part of screen so that I can explain it there. So now this is limit, I am writing it afresh, limit n tends to infinity, e to the power minus 1 over, this I can write this as n over 2. Why I am writing like this? Because n over 2 is nothing but h. N over 2 is nothing but h. And what is this? This is e to the power nh minus 1 over e to the power h minus 1. And since we have to use limit, then I think we should go this way. But always keep this in your head that limit n tends to infinity is equivalent to or identical to h tends to 0. So wherever I need n, I will just use that one. So what I am trying to say is e to the power minus 1 is constant. So this n minus 1, n minus n by 2 can be written as h. So this is my h. Okay. Now n by 2 is h. So this is my h. So this upon n by 2. Okay. I think we should get our h here. And then this h will finally come here as h. This is gone. Now this becomes limit n tends to infinity e to the power minus 1. This is constant. So this you can write here e to the power minus 1. And this one is e to the power nh minus 1 into 1 upon limit h tends to 0 e to the power h minus 1 upon h. This becomes 1. This is the formula we all know. So we are just having e to the power minus 1 limit n tends to infinity e to the power nh. What is nh? 2. So e to the power 2 minus 1. In this expression, if you write n tends to infinity, there is no n. So it will be e to the power minus 1 into e square minus 1. If you expand, this becomes e minus 1 over e, or e minus e to the power minus 1. Now let's just check whether we are getting the same thing. So first you just expand this whole thing, this one. So integration of e to the power x is just e to the power x. Then the lower limit is minus 1, upper is 1. So this is e to the power 1 minus e to the power minus 1. Now you see, you are getting the same thing. It means this is done. So this is how this question can be solved. But for that you need to practice a lot. Then only you get the better confidence. So this is all for definite integration as a limit of sum. Next video will solve some more questions of the definite integrations and the properties of the definite integration. That is very important. Subscribe to our channel, share it with your friends if you feel like they should also know. Otherwise everything is fine. Just stay happy and stay safe.